Good evening, students. In this video, I am going to explain you the concept of flow through the pipe and what are the types of losses when the fluid is flowing through the pipe and how to calculate that losses. Before starting this video, I just like to explain you one thing, that this is module number 4 of the fluid mechanics, that is real flow fluid. And if you see the syllabus, in the first part there is a theoretical concept like when the fluid is flowing, when the flow is laminar, when the flow is turbulent, then what are the types of velocity distributions. That part I will explain after this concept. First I am explaining this part because on this point there are many numericals which are asked in the exam, and for the only theoretical part, that is only theoretical concepts are asked on the first part of this module. So after completing this part, we will go to the next level. So I hope you will understood this part. You just listen the video carefully, just look out the images which I have shared carefully so that you will understand easily. This is a very simple concept. So as you see, the model name is real flow fluid. So when the fluid is flowing through the pipe, Shamit, please. Now, as you see, the pipe flow, when we can say the fluid is flowing through the pipe only when a pipe is a closed conduit, generally circular in section, which is used to carry fluid under pressure. Now, the flow in the pipe is termed as pipe flow only when the fluid is completely filled across the cross section. There is no free surface of fluid. That means, in simple word, we can say the pipe should be fully filled with the water or any fluid, then we can say it is a pipe flow. Otherwise we will say it as a open channel flow. Now when the fluid is flowing from one section to the another section, for example, take one example, we have the water tanks, large water tanks in our city or in your local area, which are used to circulate the water in the different sections of the city. So there is the one point, that is that the water tank, and another is our home. So whenever the water is reaching from the tank to our home, it travels more, and while traveling the loss is occurs. Now what do you mean by that loss? The loss is nothing but the loss of energy, and we can say it is a head. Now if you just remember, we have seen different types of head, different types of energy in the form of head while studying the Bernoulli's equation. What do you mean by Bernoulli's equation? It is simply says that the energy remains constant, that is potential energy, kinetic energy, and pressure energy. We have already studied the Bernoulli's equation says that P1 upon rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 is equal to constant. Now that P1 by rho g is nothing but the pressure head, V1 square by 2g is nothing but the kinetic energy head, and the Z is nothing but the potential energy head. So these three types of energy get lost while flowing the fluid from one point to the another point. Now how these losses are classified? In this way, the energy losses classified into two parts. First is the major loss. The major loss occurs due to friction, and another is the minor energy loss. Now the minor energy losses are there because of the sudden expansion, sudden contraction, the bend in the pipe fittings, the obstruction in the pipe, the walls which are located in the pipe, when the fluid enters into the pipe, when the fluid leaves the pipe. These are all types of losses we have to consider. The main part, important part, that is the major losses. Now if you just understood the types of energy losses, then I have to tell you that the numericals are asked on this, that the major, calculate the major loss and calculate the minor loss. So one by one we will see what are that major losses and how to calculate that major and minor losses. Now in the next part, what do you mean by first major loss? Major loss is due to friction. Now what do you mean by what type of friction it is? So the fluid flowing in the pipe is always subjected to resistance due to shear forces between the fluid particles and the boundary wall of the pipe, and between the fluid particles themselves, resulting from the viscosity of the fluid. Now this resistance to the flow is called as a frictional resistance, and loss of head due to that is called as a friction loss. Now this friction loss depend upon the type of flow. That means whether the flow is a laminar flow or the flow is a turbulent flow. Now if you just look at the formula, there are two formulas available to calculate the major loss due to friction. And if you just see, in the percentage of this loss is up to 80 to 90%, and the minor losses we will consider that are only 10 to 20%. Now there are two formulas available to calculate the major losses. First one is the Darcy-Weisbach formula and another is the Chase's formula. In our syllabus we have to just look at into the Darcy-Weisbach formula, and there is no derivation for the Darcy-Weisbach formula. You have to directly use the formula. Now if you just look at into the Darcy-Weisbach formula, you will see the HF, the word HF used for the loss of heat due to friction, and we will use the symbol HL or HL to calculate the minor losses, or we will use any symbol. Now if you see the formula, the Darcy-Weisbach formula is 4FL V square upon 2GD. Now the term 4F, now just remember while solving the numerical, whenever I will in this just remember this formula, how to use and why this formula is there. That concept I will explain in the next part, that is when the what do you mean by head and what do you mean by when the one point is given and another point is given, and what do you mean by that head loss, that you will understood in the examples. Before that, just explain what do you mean by this Darcy-Weisbach formula. The HF is equal to 4FL V square upon 2GD. Now this 4F, now 4F is the constant term. Now whenever, just remember the formula, if you just look at different books, there are two formulas. One is the FLV square upon 2GD and another is the 4FLV square upon 2GD. So what is the difference? Why the 4 is not taken in the few formulas? So remember, it is just simply 4F is nothing but whenever the 4 is coming with the F, it is a coefficient of friction, and when only F is given, it is simply nothing but the friction factor given. So how to identify that I will explain when we are solving the numericals and while the given data is given. Now L is nothing but the length of the pipe, V is nothing but the velocity of the pipe, velocity of the fluid flowing through the pipe, D is the diameter of the pipe, and G is the constant. So to calculate the major loss, the Darcy-Weisbach formula is used, that is 4FL V square upon 2GD. Have you understood this formula? Nextly, the value, the Reynolds number for the laminar flow, we can use this to calculate the value of F, that is coefficient of friction, if it is not given in the example but the Reynolds number is given, then we can calculate that value of F by using, if the flow is laminar, we have to simply use the formula 16 upon Reynolds number, and if the flow is turbulent, then we have to use 0.079 upon Reynolds number raised to 1 by 4 for the turbulent flow. So this is the simple Darcy-Weisbach formula which we have to use to calculate the major losses. I think you have